so these are the book ones I'm going over. And again, try these on your own first. It's always going to help you do better. And then if you make mistakes, you actually learn more if you make the mistake first and get it corrected. So there's 6 cars traveling together, 2 people in the front seat, 3 in the back. Write an expression using the numbers 6, 2, and 3 and the symbols and parentheses if needed. If you use parentheses, explain why you need them. If you do not need them, explain why you do not need them. All right. So if I look at this, I have 6 groups of 2 plus 3 and 2 adults and say 3 kids in the back seat. I need parentheses because I want to total up the people before I multiply by the 6 cars. So I need the parentheses because if I want to add that there's 5 people per car, I need parentheses to say to add first before I multiply by the 6. All right, so for part B, a collection of things that would 6 times 2 times 3. Okay, so this would be maybe I could have 6 cars again with only 2 people in them and another car with 3. Or I could maybe have, say I have 6 baskets. So I have 1, 2, 3, 4, 5, 6 baskets. And say in each basket there's 2 cookies. And then I also have, say, maybe 3 cookies on a plate or something like that. So maybe there's a plate over here with 3 cookies. So then how many cookies do I have? So I have 6 baskets that have 2 cookies in each. And then I also have 3 extra cookies on a plate. How many cookies do I have total? And again, I have kind of 2 sets of things going on there. Notice here the 2 and 3 are connected, like front seat and back seat people. So I get a total number of people. And the 6 is the cars. Here I have 6 groups of 2, but then I have kind of like this extra thing that has nothing to do with the 6, right? There's not 6 sets of 3. Here there's 6 sets of 2 and 6 sets of 3. Here there's just 6 sets of 2 cookies with 3 extra. So that's a little bit different. All right, let's look at number 3. So the teacher has 7 tables that have 4 kids each, 2 tables that have 3 kids each. Write an expression and then talk about the parentheses. All right. So I have these 6 groups of 4 kids, okay, and I could do this. Plus, I could have, 2 groups of 3 kids. And here I'm just using the multiplication parenthesis. I'm not really grouping it, okay? But I could group it. I could say, well, these are grouped together and these are grouped together. But do I need to? If I just say 6 times 4 and 2 times 3, would I still get the same answer? And the answer is you don't really need parentheses there. Because multiplication groups these together because they're touching, and this groups these together because we add last and we get 30 kids. So if I group them, it's fine. I mean, I could say that these go together and these, but they automatically go together because you, please excuse my dear Aunt Sally, right? You multiply before you add. So in this case, parentheses are not necessary. Okay, the parentheses are really not needed here. If you write it just like that, it's fine, whether you have the parentheses or not. So you don't really need the parentheses there. All right, let's look at number 4. Describe a collection of things who would be this and another expression that would be that. So kind of similar to what we had before. Again, I could have 8, say, baskets. And in the baskets could be 4 candy bars and maybe 2 apples. Right, so here I have my 8 baskets, and in them each one gets 4 candy bars. Should have drawn this in advance. This is going to take a while. So here's little kind of square candy bars, but whatever. You guys get the point. So there are my candy bars. Right, and then there's 2 apples. I'll just draw circles here for my, well, they kind of look the same here. I'll put little stems on them. So my apples, I'm not the best drawer, you can tell. Okay, all right, and so that would be a problem that would do that. So I have 8 baskets, each basket has 4 candy bars and 2 apples, and then the question would be how many total treats do I have, okay, or how many total items do I have, all right? So this one could be that I have 8 baskets, again, or bags or whatever, of 4 candy bars. Plus I have 2 maybe extra, and again, maybe I have 2 extra candy bars on the counter. So here I have 8 baskets with 4 candy bars, so I still have my 8 baskets, but this time they just have, I'm going to put 4 candy bars in each. I'm not going to draw the pictures this time. All right, so I have 8 times 4 is 32 total, but then I just have these extra 2 candy bars kind of sitting on the counter, so I have 34 candy bars total. All right, so here the question would be like something about that I have 8 baskets with 4 candy bars each. I have an extra 2 candy bars sitting on the counter. How many candy bars do I have total? All right, where this one is going to say I have 8 baskets filled with 4 candy bars and 2 apples each. How many total items are in all my baskets? So on that one, you might, depends on what you do, but you might total these guys first and get that you have 6 items and then get 48 items total, okay? And then question 5 kind of actually goes back to this picture, okay? So if we switch gears and we go to question number 5, it says there are 6 cars, which is what we had here, traveling together. We have 2 people in the front, 3 in the back. Explain how to use it to do the distributive property. So we have part of it done. So let's just use this picture that we already drew. I'm going to use the distributive property, which would be 6 times 2 plus 6 times 3. So this will be 12 plus 18, which is 30. Okay, now I only draw one picture, so I'm not drawing 2 different pictures here. I have one picture that demonstrates both math. So how does it show that? Well, it shows that on this side, you can get the total number of people. So you can total the people first and then take 6 groups of 5 people to get an answer of 30. So 30 people. Or you can look at say the front row people and get the total for them. So the front row people are 12. Okay, so I might circle them in green. So instead of totaling the cars, I could total the front row people, which is 6 cars with 12 people in the front row. So I could total front row people first. And then I could total the back seat people second. So that would be this math. I'm focusing on the back seat people. So total back seat people. And then I could total them later. So then, get the final total at the end. So this picture demonstrates the distributive property because it's showing that 6 cars, if I total the people per car, 6 groups of 5 people is going to give me 30 people, which is the correct answer. But if I focus on just the front row people and the back row people and kind of get a subtotal of them, when I add them together, I'm still going to get 30 people. So a kid can see the 5 people per car to get the 30, but they can also see the front row people and the back row people to get 30. And so that shows that the distributive property works. And again, remember, it's a distributive property of multiplication over addition. So there's multiplication involved and addition, which is pretty rare for properties. All right, hopefully that helps, and good luck on the rest of the problems.